Yeah. Guys, okay, ready?
Okay. Well, first of all, thanks, Bill, for putting this all together. It's good to get some activity in the north, because I'm very conscious the BATC tends to be a bit south-centred, shall we say. But, okay. I'm, most of you probably know me, Dave. I've been chairman of the BATC for nearly 4 years now, but been involved in amateur TV since about 1976, I think. And what I'm going to do today, let's share the screen so that you can see what's going on. Share. Are you getting that?
Yes. Yes.
Good. Okay. Is give a quick update on the status of the BATC and our projects. Update on the club, Portsdown, Langston, Ryde, which I think you've all seen this morning, and Winter Hill, and then just a little on the latest developments. As far as the club's concerned, we're quite happy with the way things are going. The membership's stable at around 1,400. Our next big event is going to be CAT and the general meeting at Coventry on August the 7th. Hope to see at least some of you there. I don't think it's too far. We can't really find a venue that's better centrally placed. That seems to be good for us. Financially, we're doing pretty well, and so that doesn't mean that we're able to support ATV projects and try and get to rallies where we can. I'm off to Dunstable first thing tomorrow. We will be at Friedrichshafen if anybody's going to that, because we've got about 300 overseas members, and we're conscious we need to support them as well. And next event in the north, I suppose, is we will be at the Microwave Round Table in early December, the one that's held at Eaton Manor in Shropshire. The other thing we do is try and do some documentation. Writing software documentation is the bane of my life, but I try and put stuff on the wiki. So, but with web and in print with CQTV. Show of hands, how many of you are BATC members? Right, be worth looking at sharing a couple of copies of CQTV around to the others if possible. Okay, let's get on to the project stuff. I'm going to talk about hardware version and what's been going on mainly with Portsdown 4. You'll be aware there are two versions of Portsdown. There's Portsdown, what we know as Portsdown 2020. I'm looking for a good opportunity to rename that Portsdown 3, because it's essentially based on a Raspberry Pi 3. You can run it with the little 3.5-inch screen that you can see on the slide there, or with the larger 7-inch screen. And that'll drive the old filter modulator board that we used to sell, or a Lime SDR or a DATV Express. The phrase I would use for that is active support. I'm not putting new features in it unless I really want to, but I'm making sure that it still works all the time. And making sure it still works is a funny one with software, because software packages get updated and they occasionally break things. So it does need a bit of work every now and then to keep it alive. The Portsdown 4 is where most of the new effort is going. Raspberry Pi 4, 7-inch screen only to start with. We've recently started supporting the DF Robot 5-inch screen, which electronically is very similar. That's why we're able to support it. And that has the added advantage of being able to drive a Pluto, but we've not supported the filter modulator board with that one. And that's in active development and mainly what I'm going to talk about. The new features then. Local web control. With the latest Portsdown 4, you can now open a browser on the LAN, type in the IP address of your Portsdown, and you'll get a screen which, one of the buttons, takes you to the desktop of the Portsdown 4, and you can then click on the buttons. It's a little bit clunky. The refresh on the screen is only once a second, but it does allow remote control. And if I know some people have used it with VNC to do distant remote control. It's only really intended for use on your own LAN, but it does mean you can control the touchscreen of your Portsdown 4 from your computer. The latest update I've just done introduced some Wi-Fi configuration so that you can actually, from the Wi-Fi config menu, you can set up a Wi-Fi network. So you don't need to plug it into a computer after you've built it to set up the Wi-Fi. An ongoing issue is each webcam that we use needs specific support. It really fooled me for a while because there are 3 versions out there of the C920 and each needs specific support. I've recently added the C930E, which Colin G4KLB uses, and the Polycom Eagle Eye USB, which has come onto the market at about £19, including postage, and is a very good camera, but unfortunately doesn't have any microphone. That's the one you can see on the left there. It looks a bit like a gecko. Last specialist feature is control of the Lime RFE, which is a rather expensive multi-band PA and preamp unit that covers all bands from sort of HF up to 3.4 gigs. But control for that is built in for those who are lucky enough to have one. Of course, the Portsdown has its own inbuilt receiver as well for working with Minitune, and I use that for all my portable operation. We've done some improvements to that. First of all, we now display the Minituner RF power level in the same way as Minitune does on Windows. The 2 numbers are more or less equivalent within about 5. I did some tests and found that if the Minituner RF power level was below 70, below -70, things weren't as good. So you need to keep it in the range sort of 70 to 50. And add preamps to make, or add amplifiers to make that happen. And you can see that's displayed here on the left-hand side with the RF input level, -50 dB on that receiver. This was Gareth G4X80 at 50 kilometers on 24 gigs last weekend. We had a really good day on Saturday, as you can see. The next improvement I made is a no scan mode. If you know the exact frequency that somebody is on, and that is exact within 1/10 of the symbol rate, so you're talking within sort of 30 kilohertz for typical operations, you can select this button at the bottom center of the screen, DVB-S2 no scan, and it doesn't mess around scanning about. It just looks on that frequency. And it only works for DVB-S2. It's just a very directed mode, and it's good for some DX work where the signals are fading in and out. You'll get a quicker lock. The other thing I've done is displayed the touchscreen mapping when you first select receive. It's just briefly displayed. You can get it up actually from the config menu if you want to have a longer study of it, but you get this screen here. So when the receiver is running, all these areas of the screen are active. I'll go through them. The top left, restart VLC. Sometimes if the signal is fading up and down, you get to the stage where VLC locks up with a blank screen or something. And whatever you do, as long as you sit there, VLC will sit there with a blank screen. If you press restart VLC, it does just that. It starts looking for valid video again. The big block on the left shows or hides those parameters you saw on the previous slide. Bottom left captures a snap, so it takes a screenshot of the screen and saves it. Now, we were looking at web access before. One of the buttons when you first go into web access is to access the snaps folder, so you can actually pull those onto your computer really easily now. Most of the screen exits back to the menu. And then on the right and left hand side, there is software control of the volume. So quite a lot of things you can do. I've been challenged with the touchscreen as to how to control it, but hopefully that makes things easier. I suppose most of my work during the year has been filling my test bench with Portsdown-based test equipment to make things, to give people a toolkit for ATV testing. I did start a couple of years ago with the signal generator. We'll look at the XY display, band viewer, which is the thing I'm most proud of, power meter, noise figure, measurement bit specialist, and the frequency sweep. But let's have a look at each of those in turn, because most people have got these sat on their bench and don't even realize they're there. The signal generator, if you've got a Lime or a Pluto or something like that, that makes a very good signal generator. I've done some approximate amplitude calibration using lookup tables. Some of the sources aren't very clean, but you know, if you're testing a receiver, you can put a signal on the frequency to test it. As time's gone on, I've expanded the number of sources. We started with just the ADF 4351 that was used in the Portsdown 2020, and this feature is in Portsdown 2020 for an ADF 4351. So you can get any frequency, I think it's from 50 megs to 4.4 gigs out of that. There's another IC that's similar, an ADF 5355, that goes up to 13.6 gigs. It'll drive that. Any connected Lime SDR mini or USB, actually I need to update that slide, it will drive that. A Pluto, it will drive that up to the Pluto top frequency, which is 6 gigs. But Colin G4EML, EML? Yes, EML, I know an ELM as well. Discovered that the 5th harmonic is really good out of a Pluto, so it makes a very good signal source for 24 gigs. On the specialist side, it'll also drive the LCOM, which is a high stability microwave source, only runs for sort of a 500 meg range, around 10.5 gigs, or the Nort SLO, which is a very similar device produced in Italy, but again, a software driven VCO. So plenty of sources there you can use. And this is what the control looks like. You know, that's generating 1.5 dBm on 1255 megs. It does show you the Lime gain there, so you can actually reproduce it if you want to as an ATV type signal. But all the signal control screens look like that. Some of them you can vary the amplitude, some you can't, depends on the source. I've got some old spectrum analyzers. I had a homebrew spectrum analyzer that I've been building over the last 30 odd years, which uses my oscilloscope as a display. But I was lucky enough to be gifted an HP 141. It was broken, got it going, but the screen on it isn't so good. And I thought, there must be a way to display this on the Portsdown. So I wrote this application that does a plot of what's on the spectrum analyzer screen, and the advantage is you can freeze it or you can normalize it. Let's show you some of that. So how do we do it? Well, you take the X and the Y outputs from the spectrum analyzer. The X is just a ramp, sorry, the Y is just a ramp. No, let's get that right. X is just a ramp, the Y is the amplitude data. Go into an interface which does analog to digital conversion, connect to the Raspberry Pi by SPI, and then show it on the 7-inch screen. And this is the sort of plot you can get out of the, so this is a 30-year-old spectrum analyzer, but you can get a really nice plot out of it using this. You can adjust the level up and down. The interface circuit, pretty simple. This was 2 ICs, I think, an LM358 and an MCP3002. Oh, and a regulator from the X input to the Y input. And this is all documented in CQTV. So we've got this plotting capability. We've also got a Lime SDR. So can't we recall, sort of take the output from that and do some sort of spectrum analysis on it? Well, we can. And the Lime SDR on the Portsdown 2020 or the Portsdown 4, or more recently the SBI Release 2 on a Portsdown 4, can act as a sort of pan adapter. So you can look at what's happening on the band. The sort of view you get is like this, and this is one I captured when I was out portable on 70 SEMS. I was on a good site, and I was trying to work M0 DTS, Rob, over on the North York Moors, who some of you will know. And you can see his signal there on the left-hand side. There was somebody else transmitting 333 kilosymbols on 437. I have no idea to this day who that was. But on the left-hand side there, you can just about see Rob's signal on 125 kilosymbols. And it wasn't quite strong enough to resolve until I put this viewer on and managed to peak the beam, got him to peak the beam. So we were able to do sort of sub-digital optimization, and we finally got a picture across. So this is one of the things that band viewer can be used for. There's also a peak hold feature on it. So if you've got a carrier that comes up on the band every now and then and you're not sure what frequency it's on, you can just put peak hold on and sit and wait, and eventually that little red line there will stick as to where that carrier's come up to. Somebody said, well, can't you make it measure power? Well, yes, you can. You need some sort of external sensor to do this. On eBay, you can buy these AD8318 modules that you can see at the top right there. They've usually got a metal can on. And using the same analog to digital converter, and I built a meter face on it. So this meter face with a bit of calibration gives you an approximate indication of how much power you're putting into that power sensor. You'll see the interface looks pretty similar to the previous one, just a different module. There. I've given the meter some inertia because a lot of the problem with digital indication is the needle waggles all over the place. I want it to look more like a real meter. You can select it to be either in dBm or milliwatts. So if you want to know, whether you've got 5 milliwatts or not, that's fine. But actually dBm is sometimes more useful. I use a lookup table for linearity. So that will vary from unit to unit. You can enter a calibration factor. So if you know your sensor is only half as sensitive, you put in 50% and it'll correct for it. You can also put in an external attenuator value. So if you've got a 40 dB high power attenuator like I've got it, you can put 40 dB attenuation into the system and it'll actually direct read the number of watts it thinks it's seeing. But I would stress it's only an alignment tool. It's not an HP432, but it is great for alignment. The biggest challenge I undertook was noise figure measurement. Now, hang on, let's just go back one. I think I might double click. No, I haven't. Okay. You can measure how sensitive a receiver is by switching a noise source on and off and looking at how much noise it receives, because clearly if the receiver itself isn't very sensitive, it won't receive much of the additional noise from the noise source. So if you've got a calibrated noise source and you switch it on and off, you then put it into your preamp or receiver and you listen to the output of your converter with a Lime SDR or something and measure how much noise is coming out with the noise source on and the noise source off. You can get an idea of how sensitive something is. So I used essentially the band viewer software to do this, but modified it. Noise figure measurement is difficult. The Lime SDR needs to be operating in the linear region. If you've got other local signals, it can affect the measurements. You need to think about what bandwidth you're measuring the noise over. And also, Raspberry Pis are dreadful for digital noise, so you need to screen it all off quite nicely. Calibrated noise sources are a problem. They're quite rare, and when you find them, they're fairly expensive. But Kevin, G3AAF, sells some RF design ones for about 60 quid, or you can homebrew them, but then, of course, you don't know how much noise is coming out of them. Noise sources tend to run off 28 volts, so we designed a switching power supply which is published in CQTV, and we sell the PCB in the shop. A nice design there from Mike G0MJW. And when you pull it up on the Portsdown, it shows you the spectrum at top left, it shows you the system noise figure on a meter on the right, and gives you an indication that the system is working in the linear range. You can also calibrate it if you know the exact noise figure, noise temperature of your source, to measure preamp gain as well. And this is my 77 preamp, which runs a noise figure about 0.8 dB and about 23 dB of gain. So that seems fairly good. Measurements on this, I would say, are accurate within 1 or 2 dB. They certainly tie up with my old analog boat anchor noise meter. But it's not an exact science. Look out for the digital noise, and if you do play with this, use some attenuators and do some error checking, make sure you get sensible results. And of course, noise sources change VSWR between on and off, so attenuators are good for sorting that out. And we've got a power meter, we've got a signal generator. How about we sweep the signal generator and measure what comes out of the power meter? And if you do that, you end up with a frequency response sweeper. So this is how it's done. Lime SDR Mini on the left, changing frequency, put a bit of attenuation in there to make sure you're not getting any mismatch. Have your device under test, then on the right hand side, another attenuator into that power head we mentioned earlier, and then you plot it and you get that sort of response. This was a filter I found in my junk box, which is on 790 megs-ish, and reasonable dynamic range, about 50 dB of dynamic range is possible. The scan speed's slower than I would like because the Lime SDR is slow to change frequency. It does respond to spuri from the source, and you know, these SDRs, third harmonic, perhaps only 15 dB down. Only currently works with the Lime SDR, but there's no reason why in the future I can't expand it given the time. So that's a lot of things that can connect to a Raspberry Pi. Most of them use an SPI, the SPI interface. So we thought it would be useful to have a standard interface on the side. And this is what I use on all of my Portsdowns now, is a 25-way D-type. And out of that, you get 12 volts power, 5 volts power, and all the data lines, so that you can just connect these interfaces without resoldering every time. That interface is defined in CQTV. I think Mike G0MJW has actually done a PC board for it, but we don't think demand is great enough to stock it in the shop. But Mike perhaps could supply one if you wanted. Has anybody built a Langston with their Portsdown? I see no hands. Is everybody still awake? Yes, good. Let's talk about Langston. It's a microwave transceiver designed by Colin G4EML. Uses a Pluto and essentially the Raspberry Pi, the Portsdown 4 hardware. More recently, it'll work with a Lime SDR on version 2. You need a compatible sound dongle. The same one is used for Portsdown, and you can actually control it by the scroll wheel on a mouse. And the sort of interface you get with this is something that looks like this. So a lot like some of the Yaesu and the like radios of today. You can select the frequency at the top using the mouse. You get an instantaneous spectrum. You also get a waterfall view. And this will do CW, USB, LSB, narrowband FM and AM. Very impressive, and covering, I can't remember what the lower limit is, I think it's 50 megs up to 6 gigs with a Pluto, up to 3.5 gigs with a Lime SDR. A very capable little microwave receiver for those of you who can't afford or don't want to go down the Yaesu route, or Icon route, which includes me. So in summary, Portsdown Langston, a single unit with touchscreen and peripherals, can do a very capable platform for all the RF activities you want. Unlike Windows, you need exactly the right peripherals. Your similar doesn't cut it. It needs to be exactly the same. It's all open source. The one exception is the DVB-T receiver, where we've had to use a manufacturer's development kit, and we have not been given the source for that. But everything else is open source, and I'm well open to people changing that and suggesting changes for me. BATC Wiki is your primary source of information for all of this. All the software is on GitHub, and I'd encourage you just to go and have a look at what it does and play with it. I'll take questions on the Portsdown at the end, but we'll talk quickly about the Ryde. I know you've had a demo of this today, set-top box with IR remote control. It needs a Raspberry Pi 4 and uses an HDMI display. It does also work with the composite video display, but to do it justice, it's worth connecting an HDMI display. It's been doing PVBS, DVB-S2 very well now for well over a year. And we've
Dave.
Going to attempt to launch it on someone else's phone.
Ah, Paul's iPhone.
I guess he's just doing it.
Yes.
Yeah. Oh, we got 2 more people.
Yeah. Everybody's now. Right, go for it, Dave.
Go for it. Okay. Thank you. Right. No problem. Let's get rid of that. And we were talking about Ryde. Can everybody hear that? Hands up if you can hear. Yep, good. Okay. I gather you're going to see a demo of the Ryde. It's a set-top box, essentially, for DATV. Works for DVB-S, DVB-S2. If you put a NUCA tuner on it, a different tuner, it'll also work for DVB-T or DVB-T2. And we're working on a stream receiver capability for it as well. So you can just select streams as channels on your TV effectively. That's being driven by having a stream receiver capability for repeaters, an HDMI stream receiver. This is a typical received picture on it. This was one I captured yesterday, and you can see it displays volume level, the MER, the margin, The power level again that I referred to earlier, frequency at bottom right there, and all the data about the signal, the service information, and the encoding in the center there. And you can turn off that overlay so you just get the picture. The overlay comes up for about 10 seconds when the picture arrives and then fades out. So really capable receiver, and as good as sensitive as Minitune on a PC or Portsdown. Winter Hill, talking to the home of Winter Hill, I'm very aware of, very capable 4-channel receiver, really optimized for QO100. With a Raspberry Pi 4 and 2 mini tuners, which of course are now back in stock. BATC has about 380 left, and that is going to be the end of stock because they're not made anymore. And works on a local HDMI display or on a network display. Okay, last bit then, talking about a few of the latest developments. These are sort of add-ons for the projects. QO100 Quick Tune, some of you may already be using, works with a Ryde, Winter Hill or Minitune, and it shows the spectrum on QO100 as on the slide here. Now this spectrum is derived from the BATC ground station at Goonhilly over the internet. It's not locally received. Shows the spectrum, and if you just click on one of the signals there, it'll tune the receiver to the right frequency and the right symbol rate so that you can watch it, and it allows for very quick tuning of signals. That's from Rob M0DTS, written very cleverly in C#. The next application, DATV Easy. Frenchman F1 EJP started writing some really good scripts to transmit DATV using high-end PCs, and they were just Windows scripts, nothing more than that. But he's now put a very nice front end on it and turned it into a transmitting application for DVB-S, DVB-S2 or DVB-T, Windows-based. This is version 1.20. Version 1.25 was issued earlier this week with even more advances on it, but he's done a really good job on this. And this just sort of builds on all of the previous work we've done and puts it in one nice package. That's F1 EJP. Information about that on the BATC forum, and I think the download has to come from the French Viva DATV site. Last one is Longmind Client, which is a Windows-based network display for the Longmind receiver. Now the setup here is you have a Raspberry Pi doing your receiving, like you would use for Portsdown or Ryde, but a dedicated one, connected to a mini tuner, and that Raspberry Pi runs custom version of Longmind. That's been having originally been written by Heather M0HMO. Phil M0DMY has modified that software to work really well over a network, and Tom has built this custom software that network controls it and provides a Windows desktop for the receiver. Just expand that to full size so you can see it. So you get the click to tune down in the bottom right of the window there. You get the picture in the top, and on the left hand side you get all the service information and some control functions. So that's a good mix of Windows and Linux capabilities there. And that wouldn't be possible without, there's at least 4 people been involved in the evolution of writing that software. So a really good community effort. And Tom has gone on, he's written a Ryde remote control using an Android phone. So lots of development going on. That's come out in the last week. So in summary, there's an awful lot going on at the moment in the software front and a little bit in the hardware front as well. Really is thanks to all the developers out there who are tinkering and publishing what they do. All this development wouldn't be possible without people actually open sourcing all their efforts. So please use them. Don't forget there's an ATV contest on the 11th, 12th of June where we get to prove to the world how much we use the bands. The other thing to bear in mind is if you have a good idea, like you get access to a good site for a repeater or something like that, there are bursaries available to fund capital expenditure that benefit the hobby. So if you submit a bursary, BATC will happily fund worthwhile causes up to about £500 for things, generating things to happen, not running costs, but capital costs. So don't be shy in applying for a bursary from the BATC to support this work. And that includes developers. If you're a impoverished developer but good at writing software, we can help you with hardware costs. So that's all I have to say, but more than happy to take any questions from the floor on any aspect.
And all of that can be demoed up here.
Any questions downstairs, Bill? Stunned silence.
You've given us an awful lot to think about, Dave.
There's a lot there, but essentially it's all to help people get on the air with TV.
Yeah, no. And we just arranged for a few more Saturdays and Sundays so we can actually have the time to do it.
Yeah. Yes, certainly need that. Any questions from upstairs, Mike?
No, it's been very good. And we've enjoyed the updates. We've got, I think, everything that you've mentioned to display. So I think I'm going to be busy this afternoon.
Good. Okay. Well, I wish you all a good day and leave you to get a cup of tea and then get into the demos, I think.
Okay. Dave, thanks again. Much appreciated.
Yes, thank you very much.
No problem. Thanks very much for watching. Cheers.
Okay.
Thanks, Dave. Maybe a catch up with you at Friedrichshafen.
Oh, hope to. Yeah, do come and see us. Yeah.
Yeah. Might even have an hour or two on the stand if you.
That'd be really good if you could, Mike. Yeah. Thank you. Okay. Bye then.
Okay. Cheers, Dave.
Thank you to all involved. Don't take your phone.